is starting at 8 of the 144 at this time, because it goes, I'll go back one, and it goes to the 20th, so it's the whole thing around. So I'm just going to play it through. I'm going to keep playing it through to where I saw something, and then I'll just bang it through. I mean, nice aurora there. Okay, it's going back through again. Let it get through the daylight. Same exact setup. There's the sun. Okay, I stopped at about 96. Okay. This is what I'm saying right here, or I'm seeing. Okay, just to get a image of where it is in retrospect to the wording there, so that we see if it's moving. It's this right here, that little spot. I mean, I'm not sure if that's moving or anything, and this is just to get a recording of it. I'm just going to click through it, because you can see everything else is moving. All the stars are moving. So what is that? See, the stars in the background are moving. There's the aurora. It's real pretty on there, even though it's black and white. Sorry about the fans and everything going. Trying to keep cool. Okay, and then it went back. Okay. Like I say, that's on the 8 where I started. Okay. Like I say, I'll just go back a little bit to show you the difference. So I'd say keep an eye on that right there, because everything, I mean, just moving backwards. Just to get this on recording. Doesn't look like it moved, but we'll see in other videos. Just going backwards. Now going forwards. So you see, all the stars are going, but what is that? Anybody have any ideas or comments? Leave them down below. It's always welcome all the time. And then it switches back over, should go over. The next one, it should be gone because it goes back to the next day, or back to the 19th. Okay, thanks a lot. Talk to you later. Bye-bye.
What we have here is the sun, or what appears to be the sun, coming up at an angle of 17.95 degrees. We have there 107.95, and you should subtract 90 degrees from that. that'll give you the angle it's at. Now we'll go forward slowly, leave that there, and as I go down to here and step forward it'll disappear. But I want you to take notice of these here, and then a white light will come up through here. So there's one there, there's one there, there's one there. That indicates a lens flare, but a smaller lens flare. You see it disappearing down here, going that direction, because the sun is going that direction. But you see how it's flaring up top there because it's a secondary sun. There's one there, one there. Flare out this way. You see there's a double. See if we can zoom in on that. A better look. Go down below, see a very bright flare, reflection, sun flare. See the secondary one underneath the building. That's this area here. See a blue dot there. So we'll just go forward slightly. See this one's jumped down. So go out. Go forward slightly. See how it's moving off to the right. You've got 1, 2, 3 colours. Up in the sky we've got this here, which appears to be a planet that accompanies the sun. I've seen it many times. When there's no lens flares, we see that quite often. So we see the flares going off to the right. And there's this thing down here again. It comes, it's almost as if it's drawing the light out towards it, and this has been elongated, whatever it is. So it just remains there. You'll see this here is a large gas planet, and it is prominent. You can see it at night sometimes, and it's a gas of some sort, probably oxygen, and it varies in size. Now it's hard to see. Now you'll notice that the light from the sun is going through it and eliminating any gas that's in there. You cannot see it, but you can see where the gas is accumulated around this side here, and it's pointing directly towards the sun. So if we run that back, you see how it's going in the same direction. And so it's barely seen there. Barely you can see it. Right, so this light here is being pulled towards it. so the magnetic field of it is quite extraordinarily high. There it is, quite prominent there. So the light's coming through, passing through the sphere itself, and because it's transparent almost, it's picking up the light on the far side and reflecting back. You just make it out there, but hard to see it on camera, I'd say. So we'll just go through, and this activity is 0. The pull ball, these things park underneath here. This the ramp opens up, and these go back inside. It's a very large building, and you can park 1 or 2 of these across on the inside underneath. But they stay there for a considerable amount of time. Now, this is the shadow of the dome. So, in other words, there's a light behind this. You can see it shining on this part of the building. And around it goes. This is part of the ramp where it lifts up. There it is. You see the sunlight, or whatever light it is, reflect on this as this moves ahead. And there's something very bright there, so much so it leaves a little dot of the centre of the light reflection. Now, what that means is that dot is not the camera lens protecting the surface of the receiver by blotting that out. You wouldn't see it there. You'd only see it up here, like the big dot you see going across space. See how the lights turn pink there? Different light source. And there's a light source here, yet this is pink here. Light source seems to be running across the horizon, just below the horizon. There's the 2 lens flares again. So the lens flare is coming off something off screen here that we can't see. So we'll bring it over. So there's the lens flare.
Morning.
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 And there it goes.
Got a mail.
And what's the light colour? Change. Pink. Light source. Now we'll go back. See that light source there? You see that changes suddenly, like so. Alright, now. running this backwards. I'm taking a slide right out, that's what you get. Usually when there's something they don't want you to see, take a slide out. And there's a sudden change in the lighting. See that? Go from that to that in seconds, 10 minutes. Now, you noticed when I was looking at the previous video that it's blue sky all day long. Now we've got light saturating this area here. There's a very strong light overhead. We go back the other way. There's something up in here. A planet of some sort. Right there. You can see it. Okay, now that is a planet. Step it back. There it is there. Let's see. Clear sky, definite planet. So we'll step it through. See these icebergs down here moving about. They've been stationary for months. Now they're starting to move. It means that the ice is starting to break free of the ice flow. Trapped in this ice is the original pollen and seed of paradise. You go down far enough, as this melts off, if that was to entirely melt the ice cap, it wouldn't raise the level of the water at all, because it is floating like a block of ice floating in a bucket or an ice cube in your cup. If you let ice cubes, we'll take a cup, fill it with ice cubes till the water is at the very top of the glass and let it melt over time, it doesn't overflow. The water stays the same height. So it's just one more thing of bullshit that comes out of university. But there's a sudden change, you see that. Alright. This last one. A lot of spectacular stuff has been happening down here. This is just the same area, different direction. You see this coming up here. A tremendously steep angle. Now, there's a planet there. You see how it magnetically gets pulled out of shape, the light. Now, what I'm trying to show you here, if I can get it to stop. Try it again. Watch the shadow going backwards now. There's light over here, comes up. Yet there's a shadow behind the building. I'll step it forward now. We don't know what that is. Possibly cloud. So we'll see a shadow on the building. Here it comes now. You'll notice this line here, it's not giving a shadow. So in other words, the angle of this is just above the tower itself. So what's that? Now that now is a shadow of that light, from this light that's behind that. That's the stick. The stick sticking straight up, that's the shadow of it. So something rising, setting, moving, whatever. But we have a light in this direction over here. Then they change the slot. See the spike of light here? So bright, it's giving up spikes. I'll get a bit more in the picture. That's coming up about 40 odd degrees. There's that little planet of some sort there. So over a 24-hour period it's moved from there to there. So there's a bright light there, yet the light is coming from this side. This side of the iceberg is lighting up. Yet there's light on the other side of the iceberg. There's light this side now, and there's the angle this is coming up at. There's that dot there. That is not lens flare, that's a planet. We've said it many, many times. This is the signs I told you to watch for, to keep looking up, and I've been saying it for a long, long time. There's the shadow going across there. There it is again. Not a lens flare. Now the lens flare accompanies something that's very, very bright. You notice when this thing comes up, and there's another light source there, and there, yet there's a shadow behind that that just went past the tower. Now there should be, if it was brighter there'd be lens flares down here, there isn't. But there is that little planet. Well, that'll do us. Keep looking up. Now these are the still shots of from Nuemeyer. We can see the shadow there of the tower and a light source in the distance. Which is that one there. See the shadow again, and then they darken it out. So that shot there and that shot there, basically not anything like that. We go back an hour and we have this light source here. Right, we go back an hour before that and we have this. And what you notice is that you see the light is hitting here on that iceberg, and this is huge, this iceberg. It might be 300, 400 feet high, and it is being, in this shot here, same angle, it's there somewhere, but the light is so bright that it actually comes across the sea, because between that and this ice flow here is the sea, and it's reflecting off the sea. So we go back that's it there. So therefore, there's no light in front of it. There's no light behind it at that point. But as we go forward in time, this is starting to brighten up. And you'll see that this here, and this here, this is an hour before. We go up and look at the next one up. There's the sun there an hour before that. So whatever this is, that's 1 hour, 2 hours, 3 hours. We go down a bit more. That's 4 hours. That's a little less than 4 hours than we got here. So the sun could not have gone around the Earth and come back to that point in 4 hours, nor can it be behind this. The sun has gone in that direction. Right? The sun goes like so. So we do a forensic information on this over the years that we've been watching it here, and all sorts of strange things happen. So you take there, that's behind in the far distance, so you've got a shadow on this side of the iceberg, shadow that side of the iceberg. So that's 1 hour later. There's the sun up here somewhere. You see the light here, or light source, I should say. And then there's a light source there. Now that's 1 hour, 2 hours. Okay. So you've got 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. These are 10 minutes apart. So there's 4 to 7. Counting hours, right? Correction there. Hour apart. These are an hour apart. That's 12 through to 15. So that's this unusual stuff that's happening down there. Look at the pictures of the one above it. So 0 to 3, 4 to 7, 8 to 11, 12 to 15, etc. Now that one is blacked out. What don't they want you to see? This was built, of course, to observe the planets coming in. They've known about them for 60 to 70 years or more. So they've been digging underground, the United States in particular. Some like $50 trillion they've spent on these underground facilities. So there's your light coming up there. An hour later, hour later, hour later. You notice that there's no night, which is what you should expect this time of year. But all these vehicles are parked out there. That's count them. It's 16 hours. that they're out of from under. Oh, there's more. There you go. All day long. Yeah, they've been out for 24 hours then. Parked, not moving.